Now, if you go back to the calculations that I said were wrong, where you take the $10 interest from the first year, multiply it by 2, and say that this is how much total interest you will have by the end of the second year. Could this be correct? Maybe sometimes under any sort of special circumstances? Yes, this could be correct, and this would be called simple interest. What would be a good example? Let's say the first year goes by, you earn your $10, you withdraw it from your bank account and spend it, or whatever you want to do with it. Give it to a friend. So how much do you have left in your bank account? The original $100, no more than that. And now during the second year, it's like you're back to year 0 starting point. You're starting your second year with a total of $100 in your bank account. And you again earn 10% on $100, which is $10. And you withdraw the interest again. Now you're back to $100, and that will be repeated every year. So if every year, as soon as you earn interest, you take it out of your account and do not leave it in the account, then every year you will be going back to the original $100 and earning interest on that. And so every year you will be earning exactly $10 in interest. $10 in year 1, another $10 in year 2, then in year 3, and so on. And in this case, to find the future value with simple interest, you would need to take the principal amount and add that times the interest rate R, which is the interest amount in dollars, multiplied by T, which is how many years worth of interest there will be. And this again can be simplified by factoring out principal and multiplying it by 1 plus R times T. So notice how the future value with simple interest formula is actually similar to the future value with compound interest formula. The only difference is here T is inside the parentheses rather than the power. This figure is from the textbook. It's figure 5.1 on future value simple interest and compound interest. And it again, illustrates what's going on with earned interest in our problem. You start with $100. 1 year later, you still have it plus $10 extra in interest. 1 more year, the second year goes by, you have earned another $10 on top. So you are at $120. So 2 years worth of simple interest. But you also have $1 extra. That is interest on interest. In the third year, you earn the simple interest of $10 again, and you earn extra interest on interest from before. So things kind of get a lot more complicated here, but the idea is with each year you earn your simple interest, so it's like you go upstairs, same height steps, $10 each. But you don't just earn that, you also earn an increasing amount of interest on interest. So you can say that compound interest, which is what's going on here with all these future values, equals simple interest plus interest on interest. It's probably intuitive to say that if you add more years to the timeline, then the future value will be higher. Because there are more years for your money to grow. The second thing you can say is that if you increase the interest rate, then your money will be bringing you a higher interest. So the money will be growing faster if we increase the interest rate. And now time to learn how to use the financial calculator. This is the list that is also in my syllabus. 3 financial calculators which are allowed in FRL 3000 class. Texas Instruments BA2 Plus or a professional version which allows for more numbers on the display and a couple other features that technically we don't need. 2. Hewlett-Packard 10B. 3. Hewlett-Packard 12C. I strongly recommend you buy the first one. Just the simple Texas Instruments BA2 Plus. This is the one I can help you with. This is the one I will be referring to in all my slides. This is the one that the textbook refers to in its chapters. And all solutions manuals again refer to this calculator. What's so special about it is the buttons that don't exist in regular calculators. For example, you see in the third row the buttons labeled as N, I/Y, PV, PMT, FV. Let's go back to our example in which you deposit $100 at 10% annual interest rate for 2 years. How would you calculate the future value? And remember, we got $121, right? Let's see how you would get it in the financial calculator. Let me bring it up right here. Turn the calculator on, then put $100, right? 100. Change it to a negative value. This is how you should enter the deposit amount correctly. So press the plus minus key. Then you want to tell the calculator what this number means. What is it? It's not the number of years, it's not the interest rate, it's the initial dollar amount. Today, at present, or the present value, PV. You press the PV button. Now the display shows PV equals negative 100. Then you want to enter the interest rate, 10% per year. Again, you start with the value, 10. Not in decimals, without the percent button, just 10. 10, and then you want to save it as the interest rate per year, I/Y, interest per year. And the third thing we need is over how many years the money will be earning interest. In our example, that's 2 years. So enter the value first, 2, and then press N, which stands for number of time periods, 2N. We are done with entering the 3 numbers that are given, and there is always 3 to find the future value. And now we want to compute the future value. Compute, CPT key, future value, FV key. Done. Going back to the negative sign that I used to save the $100 deposit amount, if I did not press it, then the only thing that would be different is the display would give me the answer with a negative sign, negative 121. So technically you can just, ignore the minus sign when you get your answer. So it's not really important yet to make sure you change some values to negative ones. But the book kind of, recommends that you learn it this way with the negative sign. Okay, what else is important? The order in which you enter the 3 numbers that are given does not matter. You can put the interest rate first, then the number of years, then the starting amount. It doesn't matter. A couple more things about financial calculators. 3 things. It's highly recommended in finance courses to increase the decimal places and to round to at least 4 decimal places. Round your answers to at least 4. The default in the financial calculator is 2, right? This is the default. That's what you have when you buy a calculator like this. How do you change the decimal places, let's say to 4, which is the minimum recommended? Press second, then format the dot, kind of the decimal place. Decimal equals 2. This is decimal, not December. Decimals is currently set at 2. You want to change it, you want to override this number. You want to change it, let's say, to 4. Just press 4. Now it has overwritten the default decimals of 2. And press enter. Done. Now you can turn the calculator off, back on, and it's now going to be rounding everything to 4 decimal places. The second thing that the textbook teaches is to try to clear the calculator before doing any new calculations or after you have done some calculations. You press second, FV, future value. By pressing second, you bring up the text in the second row. So let's try again, second, FV. Now everything is cleared, so there is nothing stored like the $100 present value, 10% annual interest rate. Everything is zeros. However, later in this class, you will realize that this is not good enough to clear your calculator's memory. Sometimes it still stores certain numbers for more complicated problems. And so my preference is doing a full reset of the calculator by pressing second, plus minus, which brings up this text in the second row, which is reset, and enter. Now everything is clear. Unfortunately, the decimal places also go down to the default number of 2. So that is a little price you're paying for making sure everything is 100% cleared in your calculator before you start something new.